How can a CSP use OpenStack in radio access networks? Well, Deutsche Telekom may just have the answer, and to tell us more, I am joined by Robert Neumann of T-Systems International and Professor Andreas Hartmann of Deutsche Telekom. Welcome to TelecomTV. Andreas, could we start by looking at the RAN? How is the radio access network evolving?
Well, yes, thank you for the question. So, I'm professor in software engineering and IT architecture, and working close together with a colleague of mine, Professor Einhaus, and he's working on 5G technologies. And since 5G is changing its architecture in the last years, and it's very heavy change. They're shifting from more hardware-specific machines to software-defined machines, and even more software is introducing, and the software needs to be managed, and it needs to be standardized. And I come into the project with Professor Einhaus and introduce standard technologies, shifting the decentralized software today into something like cloud architectures. And therefore we need cloud architecture standards, and OpenStack may be one of the solutions in future for that standardization.
And Robert, you're obviously using the Open Telekom Cloud. Tell me more about Deutsche Telekom's cloud platform.
Yeah, the Open Telekom Cloud is an OpenStack platform. It's developed by our partner, the Huawei, and we provide this as an CSP in Germany. And beside that, we have an integration of a lot of services which are integrated directly in OpenStack, like network and compute resources. And for this reason, what they researched at the Hochschule für Telecommunications, Leipzig, that is a good solution to provide the resources of them.
So, talk us through what you're doing for the research. How are you setting this up, and what elements are in place?
Just imagine, we are right in the start of the research project. And in the past, so I'm a software engineer. I didn't know so much about 5G and high frequencies, but just imagine we have all the clients with their smartphones, and the smartphones are being connected to what we know as an antenna. Behind the antenna there comes many software and many hardware into the place, taking care about the communication, taking care about your internet traffic being routed to some servers in the internet. And this is very complex and has been used inside single specific high specialized machines. And now we are shifting those ingredients, those software components, into virtualized containers. Right now we're using Docker, but it can be replaced with better technologies in the future. And this is the first step to shift the software from a virtualized machine, which is right in our research environment today, shift that software to the OpenStack infrastructure, which is being installed at Open Telekom Cloud. And this is the first step to make this software more flexible, more adaptable in the future. But we, as I said, we right at the start. There's much more to do.
So you have to make changes to the Telecom Cloud to accommodate this?
Currently not really, but we have integrated a new feature that is also provided at our booth. This, for example, the hybrid cloud. That's an edge computing component, so that the client can place a rack in this company or in this compute resource area to have a separate part for his cloud access to them. So that could be a usable feature which is necessary to provide the components for the future of the communication. Yeah.
And you're using open networking technologies and projects for this. How important is it that you approach a project like this? Unlike the past, you approach a project like this with the full knowledge that you're going to have the support of the open community.
We need as much knowledge and as much future technology and ideas as possible. And just imagine how many base stations are being installed that you use to connect your smartphone to the internet. And just imagine how many effort is needed to keep those stations up to date. Just talking about security issues. And in the future you don't want people to go to the stations and doing the updates manually. So we need to control them over the cloud. So it's easy to say. And this needs to be done. This needs to be implemented. This needs to be designed. And that's a big question of the project.
And I guess OpenStack is the way of choice to run this. Is OpenStack here to stay in these environments, telco environments?
Yeah, sure. That's the main feature of OpenStack is it's open source. So everyone is involved or invited to develop it with the customers and with the clients. They use OpenStack. So I think it's a very important key feature of OpenStack because closed source will not be help for the future.
And a final question. You said you're at the early stages of this.
Yes.
What is it you hope to learn? Are there any key areas that you really want to reach or understand more?
Speaking of me, my big goal is to introduce an open and widely accepted standard into the telecommunication 5G research, because I don't want those people, including me, to invent something new. Since we already have OpenStack and we have the community, and although as well we have high requirements to the infrastructure, and maybe some other people are just doing research, bringing solutions to the high requirements, and we can profit from this and use it as well, and so it's easier for the future.
Right, great. And Robert, what's your goals?
Yeah, the goals for us is to understand how we can support some research projects with our infrastructure to fit their needs, for the understanding to integrate new services in the cloud projects, for example, and to do not work duplicated, like development own solutions by using OpenStack or open source software. Yeah.
Well, terrific. Well, best of luck to both of you for this work, and I hope that sometime in the future we'll find out some results and we'll learn something.
And to just to give you some sentence from my colleague Professor Einhaus, he says maybe in future the shift from 5G to 6G is just a software update.
Yeah.
We'd like to see that.
That's what we hope.
Yes.
Andreas and Robert,
so much.
thank you very much.
Thank you too.